All right, so we ended on this point that the fact that we can reverse our row operations means that our elementary matrices are invertible. So let's look at the inverses of those same elementary matrices we found. So if you go back in your notes, remember E1, where we just switched R1 and R3. Well, the inverse would be switching them back. All right, so E1 inverse is actually 0, 0, 1, 0, 1, 0, 1, 0, 0. All right, so what's the opposite of switching row 1 and row 3? It's switching row 3 and row 1. So it's going to be the same. Let's see if I can find it in our previous notes. All right, so taking the identity, switching row 3 and row 1, we get this as the result. Okay. All right, we can do this with E2 that we found, that inverse. 1, 0, 0, 0, 1, 0, 0, 0, 1, 4. All right, so what did we do here? Elementary matrix number 2, we scaled by 4. Well, the inverse of that would be scaling by 1/4. All right, so how do we get this 4 to be a 1 again? 1/4. All right, so this operation is updating R3 by scaling by R 1/4. And finally, for the third elementary matrix, its inverse. Let's see, what did we do here? So here we multiplied by -3 and added it. So the opposite of that would be multiplying by a +3 and adding it. That's how we would undo this. One, 0, 0, 0, 1, 3, 0, 0, 1. So this is taking R2 and updating it by multiplying by R3 plus R2. All right, so these are the inverses of those elementary matrices that we found, and these are also elementary matrices. So note that if we took the original E1 and multiplied it by this E1 inverse that we found, you can do this on your own if you are not convinced this is true. When you multiply them, you should get the identity. Same here, when you multiply E2 and E2 inverse, this thing here times E2, we'll get the identity. All right, so now let's get to the nitty-gritty of this point. I promise the point is coming soon here. Let us suppose that A can be row reduced to the identity matrix. So let's say we have A, perform all these row operations, and we get the identity. Remember, performing row operations is the same as multiplying by elementary matrices. So let's list those. So we're going to let E1, E2, all the way to EP, so these are all elementary matrices, be the elementary matrices corresponding to those row operations. All right, so A can be row reduced to I by multiplying these by A. When you multiply these by A, you're going to get the identity. All right, so that means if we have EP, EP minus 1, all the way to E1 times A, That's going to be the identity. So that means all of these elementary matrices together, can you guess what they make up together if we multiply them by A and get the identity? All of them together, that's A inverse. A inverse times A gives us the identity. So that means to find A inverse, this is an A, we need to multiply these elementary matrices. Which, remember, these elementary matrices represent elementary row operations. So, to find A inverse, we just need to apply the exact same row operations to the identity. That's it. If we apply these row operations to the identity, we're going to get our A back out. All right, so here's what it's going to look like. We are going to set up an augmented matrix. Surprise, surprise. But it's going to look a little different. All right, so on one half of the augmented matrix, we're going to have our original n by n matrix A. On the other half, we're going to have the identity matrix. All right, then we're going to row reduce until we get A into RREF. All right, so we're going to pretend like we do all that work. And then one of two things will happen. When we row reduce, what's going to happen is you're going to row reduce A and it's going to turn into I, and I is going to turn into the inverse. So we'll have the identity on the left side, A inverse on the right side. And this only happens if A is invertible. But what if A is not invertible? Then what's going to happen on the left side, we're going to get something that's not the identity. And on the right side, we're going to get junk. And this is going to happen if A is not invertible. So great things will happen if A is invertible. Nonsense will happen if A is not invertible. All right, so in the next video, I'm going to do an example of this.